Good morning, YouTubers. It's Saturday, November 16th, 2019, and I'm wanting to produce this video in response to a video produced by AutoExperts.com, John Cadogan out of Australia, and he was doing a video on hybrids, plug-ins, and electric vehicles. Versus internal combustion engines, and I felt some of these conclusions were fundamentally wrong. And the basic thing I had objected to, that is he had a writer a subscriber that wrote in and asked him questions about what was preferable for his driving mix, which was heavily weighted towards highway driving, and Cadogan ended up recommending a diesel for him, and I think his conclusions are just fundamentally wrong. One of the first things I objected to is this idea that internal combustion engines are naturally more efficient on the highway and less efficient in the city driving, and that plug-ins have no advantage on the highway, and internal combustions, of course, do, because they're still internal combustion. That, of course, in itself makes no sense. If they're both still operating on internal combustion, then they're the same. But anyway, and then there's this idea that city driving, of course, is where they shine. So it was a waste of time to buy a plug-in or a hybrid electric for a heavily weighted driving mix, towards highway driving. And I just think this all stems from a fundamental misunderstanding about how vehicles really operate. And what I have back here, as you can see in the distance, is a graph. And this is the graph of the performance of a Tesla Model 3. And on the right is the vertical columns in kilowatts, and across the bottom, of course, is miles per hour. And it culminates here at 100 miles per hour at 86 miles per gallon, doing it at a steady state speed. And it would have 197 miles of range. And this is at a 0.23 drag coefficient. Now the whole point of this graph is it doesn't matter what powers this vehicle. It can be an internal combustion engine or anything else. And it would still say the same. The power required to move this shape through the air would still be the same. Now the gasoline engine might use 3 times more energy in the form of gasoline, which it would turn around and waste, 75–80% of that energy driving the rear wheels. But it would still require the same amount of energy to move that body shape with that rolling resistance through the air at these speeds. And it's all graphed out here. And at the bottom, you can see a red zone, and that is rolling resistance. And as you can see, it's linear. But the aerodynamics really takes over. Once you get above 20 miles per hour, it begins to take off. And it goes higher and higher at a faster rate until you reach 100 miles per hour right here. So but the other thing you might see on this graph is that here's 40 miles per hour right here, and it takes at 40 miles per hour it takes 6.1 kilowatts to move through the air. And so this is all this zone here, 40 miles per hour this way. And that's what it takes to move this vehicle through the air, even at speeds what we consider to be city driving. Now, the only reason that internal combustion engines get poorer fuel mileage in the city than they do on the highway is the stop and go. If you could drive at city speeds, and by that I'm going to define as less than 40 miles per hour, no more than 40 miles per hour, then you would be able to get higher gas mileage in city driving than you would on the highway. It's only the stop and go where you throw away all your momentum, you lose that energy to braking friction, and then you have to restart the mass of the vehicle and get it back up to speed again, from light to light to light. And this is why hybrid electrics shine. They recapture some of this energy in the form of regen braking. When they're stopped at the light, the engine is not idling, the motor's just off, and when they take off again, they reuse some of this energy. That said, even a hybrid would get better fuel mileage in the city if it didn't have to experience stop and go driving. And this is a really formal misunderstanding that most people have about this equation. And so all vehicles at slower speeds will get higher MPGs than they will at higher speeds. Now my pickup truck, for example, it's a Ford F-150 with a 3.5 liter EcoBoost engine, and it's capable of 33 miles per gallon at 40 miles per hour. And that's only about 18 horsepower. It's all it's using out of all that power that it has. So, anyway, back to what I'm saying. You could reverse these MPG equations simply by getting rid of stop and go driving in city driving. So, and the same thing's true at higher speeds. Whatever speed you're traveling, 60, 70, 80 miles per hour, 100 miles per hour, it doesn't matter. That shape and those tires it cause a certain amount of counterforce due to aerodynamic drag and rolling resistance. And that's what the engine has to overcome. Now, the point I was trying to make about my truck was at 40 miles per hour, it's still only in fifth gear. It's only when I get to 45 miles per hour, it gets out of fifth gear and into sixth gear, at which point I might get slightly better gas mileage because the engine RPMs really can drop. But I normally don't drive at 45 miles per hour. I have a 40 mile per hour zone, which is several miles long, and I can drive in. And so I have more experience with that. But at any rate, so what I did is I got curious and I drew up a list of vehicles here. And I wanted to give internal combustion engine the benefit of the doubt. So on this column over here, ICE, I picked a Honda Civic, which is rated at 32 miles per gallon in the city and 42 miles per gallon on the highway. I picked an HEV, and I wanted to give HEVs the benefit of the doubt, so I picked a Hyundai Ioniq, which is capable of 44 miles per gallon in the city and 42 on the highway. And then I picked the plug-in version of that, which for 29 miles under battery-only operation is capable of 119 miles per gallon. And then for the last column over here, I picked the battery electric vehicle. I went ahead and I picked the Tesla Model 3. So that's why I have the T/BEV. And the results are pretty astounding. The total cost for 15,000 miles a year for the gas engine was $1,067. Now this is all given a certain set of assumptions that I have to deal with here. That's $2.50 a gallon gasoline. I'm paying 12 cents a kilowatt hour for electricity. And what I broke it down in, and again, given the benefit of the doubt, out of 15,000 miles, 3,000 miles of that was travel on the highway. And then of the remaining 80%, 40% of that was highway driving, and 40% of it was city driving. So, and I broke it all down. $1,067 a year. It's took 427 gallons and emitted 4.18 tons of CO2. And the HEV, with a similar breakdown, was $875, took 350 gallons of fuel, and emitted 3.42 tons of CO2. So it's 82%. So in other words, you're doing about 18% better driving this HEV over the other. Now it's up to you to make your decision on the price premium or anything else, or if you want to be more environmentally friendly. But that doesn't mean it's not worth doing. Vehicles, all kinds of vehicles, even gasoline, if you just buy gasoline vehicles, some of them cost more and some of them cost less. So if you want those qualities in an HEV, and it costs more, but you want those qualities, you don't want a vehicle that's setting at lights and with the engine idling, and you want to reduce air pollution and environmental impacts, you would go that route. It's just that simple. So these are value judgments. They have nothing to do with engineering judgments. Now the PHEV does even better. It costs $755 a year to operate under these conditions, produces 2.09 tons of carbon, and uses 264 gallons of gasoline. So it's using only 62% of the gasoline. The PHEV only needs 62% of the amount of gasoline that the really efficient internal combustion engine car needs. So it's doing almost about 38% better. I think that's really significant. And its carbon is down to 2.09 tons a year. So anyway, it's almost been cut in half. So the final one is the battery electric vehicle, which is the Tesla. And the reason I picked Tesla is because of the charging infrastructure. And not only that, it's one of the most efficient vehicles on the planet. At 123 miles per gallon on the highway and 130 miles per gallon in the city. Excuse me, that's probably the reverse. But at any rate, it ended up using $520 a year to operate, which is basically you've cut your operating costs in half, down to 49%. It producing 0 tons of carbon per year. And the reason I'm saying that is because my home's powered with solar and I charge with solar. And I don't even know the sources anyway. If I were traveling, I wouldn't know exactly where the power is coming from. And we have a pretty good mix here in southern New Mexico and the United States. So, in fact is El Paso Electric claims that they don't have any coal at all. And I guess they have gas peaking plants and lots of solar and wind in this state. So, but it was 119 gallons equivalent, which is 28% of the energy that it took to drive the Honda Civic. For the same miles, same driving conditions, same mix of driving. So there you are. And so that's it. You have a 50% reduction with a pure electric vehicle. You have a reduction with a plug-in of, what was it? About 40% reduction, and about 20% reduction with a hybrid electric. So I'm going to have to go now because I'm running out of time. But I think this graph is the most important thing here. Aerodynamics and rolling resistance, that's it. And the engines are irrelevant. That's the power it takes to move the vehicle through the air. Now, if the engine wants to throw that energy away, it'll do it. Talk to you later. Bye.